I have a couple of examples of problems that involve inequalities. This first one is showing us a graphic, and it says the following represents an inequality. So I've got three boxes here. One of them I've got these long poles inside of, plus these little diamonds. That's box number one. Here in box number two, I just have little diamonds, and here in box number three, this is my key. This is going to tell me how to read the rest of the information here. Okay, so let me get rid of these little arrows. Okay. Well, my key says that each of these long boxes, the long rectangles, are an X, and each of the little diamonds here represents -1. Okay, so we really just have to count what's inside box number 1 and box number 2 in order to write this in numbers. Okay, so here in box number 1, I've got 1, 2, 3, 4, 5 of these X's. Okay, so I'm going to write that as 5x because that's the same thing as x plus x plus x 5 times. Okay, and here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the little diamonds. But when you're writing this out in numbers, it's important to remember that each of these are -1. So here I would have -10. Okay. My inequality sign, the less than or equals to, that needs to stay exactly the same. So I'm going to plot that in right here. And then finally in box number 2, I just have to count my little diamonds. So I've got 1, 2, 3, 4, 5 of those. But again, remember, these are -1, so I'm really subtracting -1 from itself, so I get -5. Okay, so just counting them up, just be cautious with your minus signs. Now, to find the solution set for this inequality, we're just going to solve it, and we're going to treat this like it is an equal sign. Okay. There is one particular rule that you have to keep in mind, and that's if you're doing any sort of division with a negative number, then the inequality sign will flip to face the other direction. But we're not going to encounter that in this problem here. So looking at my written inequality, to solve this for x, I can add 10 to both sides, plus 10. Okay, so this 5x stays here. This canceled out. I still have my inequality. And 10 minus 5 gives me +5. So again, I'm looking at 5x is less than or equal to 5. In order to solve this for x, I'm going to divide both sides by 5. My 5 is positive, so I don't have to worry about changing the direction of my inequality sign. So these 5's cancel out to 1, and I'm left with x is less than or equal to 5 divided by 5 is 1. And we call it the solution set because it could be any number that's less than 1. It could be -5. Anything smaller than 1 or 1 itself is going to keep this inequality what we call a true statement. The other example I have is a word problem. It says Grandpa Joe gave Joseph 400 baseball cards. Once a month, Joseph goes and buys 75 more cards. Write an inequality that can be used to find out m, the number of months after starting his collection that Joseph will have more than 1,000 cards, and then solve for m. Okay, so Joseph initially gets a gift from Grandpa Joe, and that is 400 baseball cards. Okay, that's what he's starting off with. Now, once a month, and that's what we're using for m here is month, Joseph's going to go and buy 75 more cards. So every month he's getting 75 more cards. So plus 75, and this is where we're going to have our m. Okay, because this is the amount that's changing. After month 2, he would have 150 more cards. Okay, and we're using inequalities here, and it says that we want to find out when he will have more than 1,000 cards. Okay, so here we're only looking at one inequality. Excuse me. So we want this to be larger than 1,000 cards. Okay. Now solving for m, we're just finding the solution set like we did in the last video. I'm going to subtract 400 minus 400. I get 75m is greater than 600. So I'm going to divide both sides by 75, divided by 75. You may have to work this out by hand, but here I get m is greater than 8. Okay, so after 8 months, Joseph would have more than 1,000